Good evening, ladies and gentlemen. My name is Keegan Ladner, and I'm presenting a project on user security concerns for blockchain security management. I'll begin by providing a bit of background information on the technology. A blockchain is a data structure characterized by the following key elements: data redundancy, a check of transaction requirements before validation, recording of transactions in sequential ordered blocks whose creation is ruled by a consensus algorithm, transactions based on public key cryptography, and possibly a transaction scripting language. That's a lot to take in. Basically, what it means is blockchains are a series of cryptographically linked blocks that contain transactional information that's signed by public and private keys that are used to validate that I have the right to make some such transaction. They're largely used in finance, but they're also used in other areas. A couple more things that are necessary to understanding how the blockchains work. There are three common types of consensus algorithms that are used. There are proof of work, which is used by Bitcoin and Ethereum, which are two of the largest chains, but others use it as well, proof of stake and delegated proof of stake. These are different ways that a blockchain validates who adds the next block, and by extension, what is in that block. And in proof of work, there is some kind of difficult mathematical puzzle that a computer has to solve, and it can only be solved by brute force, which means that statistically speaking, the most hashing power is going to win overall, but they use that to choose who's going to put the new block in. This is the one used by Ethereum, which, well, I will be talking about more. Proof of stake, instead of using hashing power, it's done by people investing a stake, and the stake increasing the chance of them choosing the next block. It's much more efficient in terms of computational power. Then you have delegated proof of stake, and that's you give up your stake to a smaller number of nodes, and those nodes will verify transactions. It's a lot faster, but it does have a trade-off of loss of decentralization. And in blockchains, the state of the chain is determined by processing all transactions in the blocks from the beginning. It's not, this is how much you have. It's, you have made these numbers of debits, these number of credits, and this is your final balance, and you have to recalculate that every single time. And information on the blocks is publicly accessible, which is necessary since a decentralized network is processing transactions. The only thing that is private is your private key. The public key is used to verify that the transactions are correct. So why does this matter to end users? Well, first of all, the market is impactful. There are commonly used in financial services, the cryptocurrencies, and blockchains currently contain billions of dollars in assets. And technology used in blockchains can revolutionize various services because it's ideal for facilitating microtransactions, and it can be used to facilitate potentially any service, meaning that this is going to have a significant impact in people's lives. In this project, I'm going to be talking about end-user security concerns on Ethereum, and I'm going to be addressing security concerns and issues faced by consumers using cryptocurrencies for purchases, not other types of users. So why Ethereum? Well, one, it's actively developed. It has a growing number of projects related to it. It's the second largest cryptocurrency by market cap, and it's a second-generation blockchain that features a Turing-complete programming language, meaning that it could potentially implement any service, and it is intended for uses beyond currency transactions because of smart contracts and its programming language mentioned before, which is Solidity. Together, they make it a interesting case to look at in terms of how can we keep users safe. So what is the problem? Well, we have confidentiality problems related to how to protect a user's private key. integrity problems related to how to ensure that only legitimate users can make transactions, and how to ensure that users retain access to their data, which is a significant issue with billions of dollars tied up in unaccessible wallets. And we have accessibility issues related to how can we make sure that users can use the blockchains in a practical way for their transaction. So what are the specific issues? Well, we have private keys that can be lost, stolen, or misplaced, just like a password. We have lost keys that cannot be recovered. Any signed transaction is legitimate, even if it's done using a stolen key. Transaction reversals are not practical since they require a hard fork of the chain, which is something that's highly controversial and doesn't happen even in cases where billions of dollars are at stake. Third-party services like cryptocurrency exchanges can be compromised and users can be affected. Code can be invalid, buggy, or subject to attack, not unlike what happened with parity wallets, where a coding error caused billions of dollars to be locked up. Millions of dollars to be locked up. And security storage of keys can be problematic for typical users since losing the key is so important and many users' use of passwords is insufficient, to say the least. So here's my solution to how we can mitigate these issues. We use a multi-signature wallet to reduce risk from a single key being lost, stolen, or misplaced, where 3 keys are used and at least 2 keys are necessary to sign a transaction. And we use a third party to verify transactions using a designated key, similar to PayPal, Amazon Pay, or other services. So basically, we have a service that just says, yes, if you sign it, we're going to say it's okay. This allows us to put an account hold on. If we're not sure if we lost the key, we can say, don't sign any of these transactions to keep my money from being used. And this potentially allows some kind of fraud analytics to be applied to reduce the risk of some kind of fraud or stolen funds. We use an additional key. We store this one so that we can recover the wallet. This one's not used on a normal basis. It's only used for recovery. And this solution would trade out decentralization for enhanced usability by typical users, trusting services much as we currently trust Visa, MasterCard, Amazon Pay, PayPal, etc. So as I was saying, this is an overview of what the model looks like. We have currency stored in a multi-signature wallet with 3 or more keys, with at least 2 keys used to sign a transaction. A user retains 1 key and uses that to sign the transaction. A second key is held by a trusted third-party service that signs any transaction signed by the user, potentially in addition to some kind of analytics to check for fraud, and another key is held securely. So a user will contact these 2 services if their key is lost, stolen, to create a new wallet with the funds transferred into that wallet, and they will continue to make transactions using the transaction key as per normal. So in conclusion, a blockchain is potentially a revolutionary way for us to make transactions and interact with service, and it uses a public-private key cryptography system, which is vulnerable to keys getting lost, stolen, or misplaced, and there's no governing authority to correct or reverse these mistakes. So we have to be more careful in how we're interacting with the chain, since private keys can be compromised in much the same way as passwords, and passwords are often misplaced, lost, or stolen. So we use a multi-signature wallet system paired with trusted third parties so that we can eliminate some of this risk by reducing the risk of a key loss or allowing wallet recovery, and to potentially screen for fraudulent activity, which our services most users anticipate but cannot be innately supported on the blockchain without using additional parties. By using this system, hopefully we can allow users to practically engage with blockchains to make cryptocurrencies a valid way for individuals to use currency without exposing themselves to significant levels of risk. Thank you, ladies and gentlemen, for your time. Have a great evening.